Okay, so this project is called Ecosight. So this one is an anti-poaching wildlife protection system. And the audio set that was used for this is mainly related to those activities that are related to poaching, like a gunshot, a dog barking, human voices, or a gunshots. So if any of these voices are recorded in a game pack, the model can actually classify all these ones into a threat that there's a poaching activity happening. So I got the data set from Kego, and the first step that I did was to augment this data set. As you can see from this was the original data set, and you can see that for gunshot we have like about 374 audios, but for other classes it's actually 1,000. So I augmented this data set into using different variations like time stretch, increasing the pitch level, and also increasing the volume. So to do this, this was actually done using the augmentation and augmented all the audios. And the final result for this was actually the total number of images that was extracted after this was this one. As you can see that the number of images have increased now to 4,000 for dog. Then the gunshot is actually like about 2,000, which is actually better for training a model. So the next part was to extract the features from this. So to extract features from this, I used a model that was already trained on different audio files that include gunshots, dogs, vehicles. So this one is found on Google on this endpoint. So what it does is different from extracting male spectrograms from an audio, but what it does, it extracts the embeddings of the audio. So this is actually what I did. And instead of passing it via a CNN, I the embeddings actually like extract the images into 1D. So I actually passed it a into the connected neural network. And this was the structure of it, like the dense, the number of layers, um, and the output, which I did like different hyperparameter tuning, like using different dropout traits for each layer. So the model was then trained, and this was the output of the model, which is this one. And I also got the JSON files for the class names, the model metadata, the performance metrics for the model and the training history. So this was all done so that I can able to visualize it in the UI. So the first part that I did was to create an API that uses this model, and also in app like the UI, the part that can be deployed in the UI using this API. So I'm gonna go to the UI of this application. So this was actually done using Docker. I put everything on Docker and it was deployed. On the UI, I used Streamlit app, which was actually better for my application. So this is the UI of this. So let me jump first to the API so that I can come back to the UI explaining everything. Because all this is found on the was hosted here on I used Rail for deploying this. So all the dataset was hosted here on Amazon S3. So these are the classes, as you can see. This was the dataset that was used for training. And the module output now was then put here on the module part. So the API now gets these datasets, or like when we upload in the metrics that are all found on using that Amazon S3 part. So I'm just gonna go through the the UI of it. So this is the UI of the application, and it shows like the performance metrics, the learning curves, and the accuracy scales. So let me just jump to prediction. So to predict a class, you can just browse to the file here. Then you can just click on the, so this one, you see this one, I put it in the class so that I can be able to verify if it's actually put it correctly. So this one is a gunshot sound and I can play it here. See, so let's just upload and try to predict and see what will be the output. So let's classify and actually it's responding as the gunshot, which is it's actually like predicting correctly the output. And have different tabs for this. And this one is actually like showing the confusion matrix for the whole training data. Then for this mode, you can also retrain it. So what I did for this one was to make sure that it triggers the retraining part for it triggers retraining when the number of samples uploaded are 100 and above. So I'm gonna copy about 100 files from this gunshot. So just give me a minute here. So let me just copy. It's gonna take some time. So I hope this is 25, 22. So it has now reached about 100. So I'm gonna open it. So as it is uploading, what it does, it uploads this to the Amazon S3 directly. So as you can see, let it finish. So this was gunshot. So you have to select a class C and put it to gunshot. So as you upload this, you will see we can go to the logs on Reo to see if there's progress for this. So this is actually happening. You see that it has uploaded this it's a gunshot and this is the audio file, so it's uploading. So it's gonna take some time to upload this. So as it is doing this, I can also be showing you the code, part for the code where this was done. So all these, so I have different scripts uh that runs all the augmentation, the retraining part, so that the files are ready for the retraining part. So it's gonna take some time, but I hope it's almost ready. Yeah. So it's taking some time, but basically, this is how the application looks like, and you can see this UI. I put it in the README or the URLs for the UI and the API. So once it's done, we can come to this part that says retrain. So since it's still uploading, we have to wait for it to finish, then we retrain our module. So now that is done uploading, you can click on the retrain part. So if you click on retrain, start retraining, you can see that retraining started. And you can also visualize this on the logs on Rail to see if there's progress happening. So this is basically how this application works, and it's done uploading. So now you see that it's progressing on the retraining part. So it starts by extracting the YAMNet. Then after that, it actually like runs it actually runs the prediction part. So it takes some time, but this is actually like how the model retrains. And thank you so much for your time.